Hello. Yeah, good afternoon, everyone. So today we'll start with indefinite integration. You know, in the last 4 classes, we have been discussing about definite area and application of derivatives we have been doing. And in that one lecture, I dedicated to tangent, normal, and rate measure. One lecture I dedicated to that is monotonicity, increasing, decreasing function, and one lecture we dedicated to maximum minima. And in the last lecture, what we have done yesterday, we did the word problems based on maximum and some PYQs we have done. All right. So with the PYQs, we get a better idea that what is there in the exam, what kind of question do come over. And if you remember, I covered all the questions which came this year only in 2024. Got it? Now today, we will start with indefinite integration. All right. So see, we all are aware that indefinite integration is the reverse process of differentiation. Yes or no? So integration is the reverse process of differentiation. Integration is the reverse process of differentiation. Yes or no? So that means if d by dx of fx plus constant, let us assume this is some capital fx. That means derivative of fx plus constant is capital Fx dx. So integration, if I apply, so integration of capital Fx dx will be small fx plus constant. So that is why I said that integration is the reverse process of differentiation. So if derivative of a is b, then integration of b is a. Got it? Now, first of all, we will do something like integration of x to the power n dx. This is the first and very standard formula, that is x to the power n plus 1 upon n plus 1 plus constant. There is no restriction on n except n should not be minus 1. Because if n is minus 1, it will be 1 by x. And uska integration, its integration is ln x. Got it? Now, so integration of x to the power n dx is what? X to the power n plus 1 upon n plus 1 plus constant. Now see, if this is in place of x, it is some linear function. Ax plus b raised to the power n dx. So the integration will be ax plus b raised to the power n plus 1 upon n plus 1 plus constant. Ax plus b raised to the power n dx is ax plus b raised to the power n plus 1 upon n plus 1. And derivative of ax plus b we divide, that is upon a plus constant. So integration may remember one thing. While applying the chain rule in integration, you only apply chain rule on a linear function because its derivative is constant. Got it? So in integration, while applying chain rule, we only assume those functions as x whose derivative is constant. That means which are linear, whose derivative is constant. And then we divide by that derivative. We divide by that derivative. Got it? Okay, we'll do certain very small questions over it. See, question number 1, integration of under root of x dx. See, it is what? This is x raised to the power 1 by 2 dx. So that would be x की power 1 by 2 plus 1 upon 1 by 2 plus 1 plus constant. So that is x raised to the power 3 by 2 upon 3 by 2 plus constant. Got it? And second question, if I have 1 by root x dx, that is x to the power minus 1 by 2 dx. Now the integration will be what? X to the power minus 1 by 2 plus 1 upon 1 minus 1 by 2 plus constant. That is x की power 1 by 2 upon 1 by 2 plus constant. That is 2 root x plus constant. Now see, if I have something like dx upon 6x plus 7 is to the power 1 by 3. Say you want to integrate it. Got it? So first of all, I will write it as like this, 6x plus 7 raised to the power minus 1 by 3 dx. So this will be what? 6 plus 7 raised to the power 1 minus 1 by 3. So it will be 2 by 3 upon 2 by 3 plus constant. Got it? Now say you want to integrate dx upon under root of x plus 1 plus under root of x minus 1. Try it for a minute. How do we integrate it? Yes, anyone? Anybody can switch on his mic and can give some suggestions? Now see, if I rationalize it, it is root x plus 1 plus root of x minus 1. You multiply it by root x plus 1 minus root x minus 1. Numerator also same, root x plus 1 minus or root x minus 1 dx. So it become root x plus 1 minus of root x minus 1 dx upon, it will be 2 in the denominator. Yes or no? So it is half came outside, integration of root x plus 1 minus of root x minus 1 dx. So this became what? X plus 1 raised to the power 3 by 2 upon 3 by 2 minus x minus 1 raised to the power 3 by 2 upon 3 by 2 plus constant. So your answer is 1/3 of x plus 1 raised to the power 3 by 2 minus x minus 1 raised to the power 3 by 2 plus constant. This is your answer. Am I correct? So it's a very important question actually. This variety is very important. Now, there are certain formula which we need to know. First of all, integration of any constant, say it is p dx, that will be simply px plus constant. Got it? That means integration of 1 dx is x plus constant. Now formulas are integration 1 by x dx as ln x plus constant. And if I ask you integration 1 upon ax plus b dx, now it will be what? Ln of ax plus b, and the quantity we assumed x divide its derivative upon a plus constant. That is derivative of ax plus b, a we divide by that. Then integration e to the power x dx will be same, e to the power x plus constant. But if it is e to the power ax plus b dx, so it will be e to the power ax plus b upon a plus constant. One thing that we are never going to do, say somehow you see something like this, e to the power x square dx. Then what do students do? E to the power x square, e to the power x square upon x square का derivative 2x plus constant. This is not we are going to do, because derivative of x square by which you divided 2x, it is not a constant. Got it? And it is not a constant. Not a constant, you cannot assume it x, and you cannot divide it by its derivative, you will get answer. Clear? Integration of a to the power x dx will be a to the power x upon ln a plus constant. And if it is a to the power px plus q dx, that will be a to the power px plus q upon ln a into derivative of this, that is p plus constant. Got it? Now, integration of sin x dx is minus of cos x, whereas the integration of, if you see somewhere, sin of ax plus b dx is minus of cos ax plus b upon a plus constant. Why I have been able to do it? Because this is a linear function. Linear function, we divide by its derivative while finding the integration. Integration of cos x dx is sin x. And similarly, integration of cos b dx is sin of ax plus b upon a plus constant. Got it? Then integration secant square x dx is tan x, because the derivative of tan x is sec square x. So integration of sec square x will be tan x. Got it? Integration of cosec square x dx is minus of cot x plus constant. Integration of sec x tan x dx is sec x plus constant. And integration of cosec x cot x dx is minus of cosecant x plus constant. So these are all the basic formulas, I would say, which have directly been derived from derivative formula. Got it? Now we'll do few questions over it, then move forward. Say you are trying to find this very simple question, x square plus 1 upon x dx. So what do I do? X square upon x plus 1 by x dx. I split the denominator. So it became x plus 1 by x dx. Now integration of x is x square by 2 plus 1 by x. Integration will be ln x plus constant. Got it? This placing this constant is very necessary. Am I clear? Now, say you have the question x upon 1 plus x dx. So how do we do it? You add 1, subtract 1 into it. Now split the numerator, x plus 1 separate. This is 1. X plus 1 separate and this 1 separate. So what do I get? 1 minus 1 over 1 plus x dx. Yes or no? Now integration of 1 is x. 1 upon 1 plus x. Integration is ln of 1 plus x plus constant. Got it? See, we have a question like x upon 1 plus x whole square dx. Then what do we do? Again, same kind of procedure. X plus 1 minus 1 upon 1 plus x whole square dx. Got it? So it will be 1 over 1 plus x minus 1 over 1 plus x whole square dx. Now 1 over 1 plus x integration is ln of 1 plus x, and 1 upon 1 plus x whole square is minus 1 upon 1 plus x plus constant. This is your answer. Got it? Okay. Try equation. Integration of e to the power 3x plus e to the power 5x upon e to the power x plus e to the power minus x dx. Try it out. Take a moment, try it. See, from the numerator, it can be written as e to the power 4x into e to the power minus x, yes or no? Plus, this e to the power 5x can be written as e to the power 4x into e to the power x upon e to the power x plus e to the power minus x dx. Now from the numerator, you can take e to the power 4x common. So it is e to the power x plus e to the power minus x upon e to the power x plus e to the power minus x dx. They both are cancelled. So you are left with integration e to the power 4x dx, that is e to the power 4x upon 4 plus constant. Got it? Very good question it is. Now I'm going to start with the integration of trigonometric functions. See, there are the only and most important thing here is the formulas of trigonometry. Like I have to calculate integration of sine square x dx. So the formula that you need to remember here is that sine square x is 1 minus cos 2x upon 2. You must know this formula. So that is what? 1 minus cos 2x by 2 dx. Take 1 by 2 outside. Integration of 1 is x and integration of 2x is sine 2x by 2 plus constant. That's it. Now, say you want to calculate cos cube x dx. Try it once. Use the formula of cos 3x. Quickly. Yes, what is the integration of cos cube x? Now see, there's another formula that I have, that is cos 3x. Cos 3x is 4 cos cube x minus 3 cos x. So from this formula, you can apply that cos cube x is cos 3x plus 3 cos x upon 4. So this will be cos 3x plus 3 cos x by 4 dx. Am I clear? Now it is 1/4 integration of cos 3x is sin 3x upon 3 plus 3 times integration of cos x is sin x plus constant. Got it? Am I clear? Now, say you want to integrate tan square x. So this tan square x can be written as sec square x minus 1 dx. Now, integration of sec square x is what? Tan x. And integration of 1 is what? X plus constant. Got it? Now, say somebody asks you dx upon 1 plus cos x. Very important question. Integration dx upon 1 plus cos x. How would you do it? So this dx upon 1 plus cos x is 1 plus cos x will be 2 cos square x by 2. Here the formula I am using is cos x equals to 2 cos square x by 2 minus 1. Cos x equals to 2 cos square x by 2 minus 1. So that is dx. So this is equals to half outside. This can be written as sec square x by 2 dx. And a formula we have seen, integration of sec square x is tan x. So it is half of tan x by 2 upon 1 by 2 plus constant. This half will cancel. So it is tan x by 2 plus constant. Am I clear? Now, integration. Say we have a question sec square x or sec square x dx. Try it once. Very good question. How would you do it? Any idea if anybody would like to speak up? See, in the denominator, I can write it sine square x or square x, and in the numerator, it will be sine square x plus cos square x. Very good. Numerator is 1 basically. So it will be, if you split it, it will be sine square x upon sine square x cos square x plus cos square x upon sine square x cos square x dx. So that would be integration sec square x plus cosec square x dx. Now sec square x integration is tan x minus plus cosecant square x integration is minus cot x plus constant. And very good, somebody answered correctly. Got it? Now see another very brilliant question, important also, that is integration a sine cube x plus b cos cube x upon sine square x into cos square x dx. Well, how do you do it? Give it a try quickly. Yes, quickly try. See, here also we'll split the denominator. So it will become a sine cube x upon sine square x cos square x plus b cos cube x upon sine square x cos square x dx. Now, this will be a. Now see, 2 sine will cancel here, 2 cos will cancel. So you are left with sine x upon cos x b cos x upon sine x sine x. Got it? Now collect them all together, sine by cos 10 and also them together. So it will be a tan x sec x dx b cot x cosec x dx. Yes or no? And now we are aware of the integration of both of them individually. So that is a sec x plus b minus cosec x plus constant. Got it? So this was all about basic integration. This was all about basic integration, very standard formula we have used. Now let's come to very important portion, that is integration by substitution. Now here we look for a function whose derivative is there in the numerator. We try to look for a function, we look for a function whose derivative is there in the numerator. Like if you have something like fx to the power n into f dash x dx. Fx to the power n into f dash x dx. Got it? So how do we do it? Let us assume this fx as d. So its derivative f dash x dx is going to be dt. So say this will convert to t to the power n and this f dash x dx will be dt. So answer will be t to the power n plus 1 upon n plus 1 plus constant. So this is fx to the power n plus 1 upon n plus 1 plus constant. Got it? Now, this is one of the form. Another very important form is, you can remember this also. With the competitive point of view, it is quite frequently used. Got it? Like for a simple example, if I take, say you have sine x to the power 4 into cos x dx. Now answer is what? Very simple. Derivative of sine x is nearby cos x. So answer will be what? Sine x to the power 5 upon 5 plus constant. Like this we can use. Or take an example like ln x to the power 100 upon x to the upon x dx. Now see, this can also be assumed as ln x to the power 100 into 1 by x dx. So you can see derivative of ln x is 1 by x dx written alongside. So answer will be what? Ln x to the power 101 upon 101 plus constant. Got it? But I insist you do not try to remember it as a formula. If it is required somewhere, so we can do it in a moment. Another form is like integration f dash x upon fx dx. Means there is something in the denominator whose derivative is right on the numerator. Total full derivative. So answer will be ln of fx, ln of denominator plus constant. But remember, it should be a full derivative. Whatever the thing is in the denominator, its total derivative should be there in the numerator. It should not be partially. Got it? And how did it come? Again, let us assume fx is t. Then f dash x dx will be what? Dt. So it will become dt by t, that is ln t, and that is this. Am I clear? Now, I'm writing two questions for you. You just give them certain thought. Got it? Question number 1 is integration of cos of sin x into cos x dx. And question number 2 is integration x cos x upon x sin x plus cos x to the power 10 dx. Try it out, both of them. Quickly try. See, this first one is take sin x as t. Because you see, if it is t, this is its derivative. Got it? So cos x dx will be dt. So it will become cos t, and cos x dx is dt. Integration of cos t is what? Sin t plus constant. So replace t back, that is sine of sin x plus constant. Very good. Very good, Pallavi. Very good, Priyanka. Now see the second one. This is something little different. If you see this, if I assume it as t, that is x sin x plus cos x as t. Now its derivative will be x cos x plus sin x minus sin x dx is dt. This sin x cancel. So what do you get? X cos x dx is dt. So your question became dt upon t to the power 10. That is t to the power minus 10 dt. So that is t to the power minus 9 upon minus 9 plus constant. So it is minus 1 upon 9, 1 upon x sin x plus cos x, whole raised to the power 9 plus constant. Got it? Now, there are 2, 3 formulas which I want to talk about. Integration of tan x. Integration of tan x. That is ln secant x plus constant. Yes or no? And how did I get it? This tan x can be written as sin x upon cos x dx. Derivative of denominator is not exactly there in the numerator, so I will extra multiply with minus. Now the derivative of denominator is there in the numerator, so minus of ln cos x, which can be written as ln cos x to the power minus 1. That is ln sec x. Got it? Now integration of cot x dx. So it will be ln sin x. Integration of cot x is ln sin x. There are two more formulas. I'll directly write it. You just remember them. Integration of sec x dx is ln of sec x plus tan x. Got it? And integration of cosec x dx is ln of cosec x minus cot x plus cos. Done? So these are few more small simple formulas that I expect you guys to remember. Now, write down a question. Integration of tan ln x by x dx. Again, same thing. Assume ln x as t. So 1 by x dx will become dt. So it will become tan t and L dx upon x. In the there it will be dt. Integration is ln sec t plus constant and then replace t by ln x. So ln sec of ln x plus constant. Easy enough? Now see, very good question. Sin 2x upon a sin square x plus b cos square x dx. Try it once. Very good question it is. Quickly try. Now, Now see, let us assume that this a sine square x plus b cos square x is t. So its derivative is 2a sin x cos x plus 2b cos x into minus sin x dx is dt. Now everybody knows this 2 sin x cos x is what? Sin 2x. So if you take sin 2x, a minus b common, dx will be dt. So this question became what? Sin 2x dx will be dt upon a minus b into t. So that is 1 upon a minus b ln t plus constant. That is 1 upon a minus b ln of t is what? A sin square x plus b cos square x plus constant. Got it? Very good question. Now there is a very important question that is from NCERT only. If you guys have seen it, integration of cos x upon cos x minus a dx. Give it a try. I hope nobody has forgotten it. Cos x upon cos x minus a dx. See, I hope you should have given it a thought. This numerator cos x can be written as cos x minus a plus a upon cos x minus a dx. Got it? Now consider them together and this separate. This became what? Cos a plus b is what? Cos a cos b minus sin a sin b. Yes or no? So it will be cos x minus a cos a minus sin x minus a sin a upon cos x minus a upon cos x minus a dx integration. Got it? Now this cos x minus a cancel. So it became cos a minus sin a into tan x minus a dx. Now what mistake some people do, that they write the integration of cos a as sin a. But since we are integrating with respect to x, this cos a is treated as a constant. So cos a will be cos a into x. Derivative of cos a will be cos a into x minus sin a common, tan x minus a will be ln of secant x minus a plus constant. Very good question it is. Got it? Now there is another very good question. This is also, I guess, from NCERT. Dx upon cos x minus a cos x minus b. Try it once, you must have seen this. Well, now let me do it. You must have tried it. It is cos x minus a cos x minus b in the denominator. So numerator I can write cos x minus a minus of x minus b dx. Isn't it? And with this numerator is what? Sorry, don't take it with cos, take it with sine. In the numerator, sine of b minus a came extra. So I will divide it by this. So it is 1 upon sine b minus a. It is sine x minus a cos x minus b minus cos x minus a sin x minus b upon cos x minus a cos x minus b upon cos x minus a cos x minus b. I split it the denominator once again. Cos x minus b cancel here, cos x minus a cancel here. So it became 1 upon sin b minus a integration tan x minus a minus of tan x minus b dx. And now we know the individual's integration. Ln of secant x minus a minus ln of secant x minus b as constant. Got it? Simple question, but it's a very good question. Now I'm writing few questions for your homework in the next class, tomorrow's class. This is Friday's class. We will start discussing with these questions. Question number 1 is integration sin 2x upon sin 8x sin 10x dx. Write down quickly. Integration sin 2x upon sin 8x sin 10x dx. Next, integration cos x upon sin x plus cos x dx. Next, integration e to the power 2x minus 1 upon e to the power 2x plus 1 dx. Root 10x upon sin x cos x dx. Then integration sin 3x sin 4x dx. That's it. These are 4 to 5 questions. You try them on your own. And whenever we catch up in the next lecture, I'll start with the discussion of these questions first. All right. So that would be all from me for today. I would like to ask you for a small feedback